In this video, we'll be solving probability exercise. The first question: if a plate of car consists of 2 letters and 4 digits, and one car is chosen at random, then find the probability that the car has the letters at the beginning and at the end. That means the plate number of the car will be formed using 2 letters. We can represent them by L1 and L2. We don't know the letters, and there will be 4 digits. Obviously, we can have here 6 characters here. So in how many ways we can arrange these 6 characters? In different ways. That's going to be 6 factorial. That is 720. This is a total arrangement. In any order, the letters at the middle or at the first or at the end doesn't matter, but total way of arrangement, these 6 characters will be done in 720 different ways. But now let's come to the restriction. The question says, in how many what is the probability of the car that has letters at the beginning and at the end? That means if the first letter at first and the second one at the end, at the middle there are 4 digit numbers, we can be that can be reshuffled. So we have 4 factorial opportunities. The same way it works when we change the place of the 2 letters, L2 at the beginning and L1 at the end. So we have 4 factorial here also. 4 factorial means it is 24, you know. You can multiply 4 times 3 times 2. The same thing here, 24. So the probability would be 24 plus 24 will be 48, the whole over 720. We can simplify. 48 is 12 times 4 and 72 is 12 times 6. Therefore, we can cut 12 from both, and in the numerator 4 left, in the denominator 6, and there is a 0 here, so 60. Still we can simplify by 4 by 4. That's going to be 1 over 15. So the probability will be 1 over 15. The next question: 2 lamps are to be chosen from a pack of 12 lamps, where 4 are defective and the rest are non-defective. There are 4 defective and obviously 8 are non-defective. Then 2 lamps will be chosen. So what is the probability both defective? The probability both defective means DD will be 4 combination 2 over 12 combination 2. You know, the total possible way of selection will be 12 2, because we have totally 12 lamps. So selecting 2 will be 12 2. That is a combination, because this is selection or choosing. Therefore 12 combination 2, let's do it. 12 combination 2, it is the same as 12 factorial over 12 minus 2, you know, it's 10 factorial times 2 factorial. Again here 12 factorial by itself is 12 times 11 times 10 factorial, so you can cancel 10 factorial with down, and 2 factorial is just 2, so by 2 1, this by 2 6, so 6 times 11 will be 66. So no need to worry about the denominator part, that is 66. Then the above part, 4 combination 2, it will be 6. You can check it, this one is simpler. So when you simplify, the answer will be 1 over 11. So the answer for the first one is 1 over 11. Because what is the probability both defective? The number of defectives are 4. The number of defectives are 4. So choosing 2 from it, 4 combination 2, and over the denominator part, it has to be 12 2, because total number of way of choosing 2 lamp will be 12 combination 2, because totally we have 12 lamps. So the answer will be 1 over 11, first one. Let's go to B. The B says 1 defective. If one of it is defective for combination 1, obviously the other necessarily will be non-defective, which is 8 combination 1. Okay, choosing 1 defective is 4 combination 1, and choosing 1 non-defective will be 8 combination 1, divided by, you know, obviously 12 combination 2. So this is going to be 4 combination 1, it's 4, and 8 combination 1, it's 8, divided by 12 combination 2 we did it already, that is 66. We can simplify here. By 2, this by 2 is 33. So that's going to be 16 over 33. We cannot simplify further. That's going to be the probability. When you go to C, what is the probability at most one defective? This is a confusing word. At most one defective means it is possible non-defective. It's possible also for no defective. At most one defective. More than one defective is not allowed. Therefore, what are the chances that I have here? One defective and one non-defective, it's okay. Plus the other possibility, both can be non-defective. 8 combination 2 divided by 12 combination 2. The total possibility will remain the same. But at most one defective means I can make it one defective and the other one non-defective, or both can be non-defective, because at most one defective. So this is the same as, for combination 1 times 8 combination 1, we did it in the above. 4 times 8, which is 32, plus 8 combination 2 has to be done, that is 8 factorial over 8 minus 2 will be 6 factorial times 2 factorial. 8 combination by means, 8 factorial is 8 times 7 times 6 factorial. Then we can simplify here, cancel 6 factorial, and by 2 1, this by 2, 4 times 7 will be 28 divided by 66. When you add it, it's going to be 60 over 66. You can simplify by 6, so it's going to be 10 over 11. This is 66. 10 over 11, that's going to be the probability of choosing at most one defective. When you go to the next one, there are 4 black, 2 red, and 4 white balls in a box. If 3 balls are chosen or selected, 3 selected at random, what is the probability that all the balls selected are black? For a case, all black means the combination 4 3, because the blacks are 4, divided by the total number of the balls are 4 plus 2, 6 plus 4, 10. 10 combination 3. So this 10 combination 3, the denominator part will remain the same for all. So we need to be focused on the above one. 4 combination 3 the same as 4 over 10 combination 3, it has to be done. That is 10 factorial over 10 minus 3, 7 factorial times 3 factorial, which is 10 times 9 times 8 times 7 factorial, the whole over 7 factorial times 3 times 2. 3 factorial is 3 times 2, When we simplify here, 7 factorial will go, and by 3 1, this by 3 3, again by 2 1, this by 2 4, and 4 times 3 12, multiplied by 10 will be 120. So the total possibilities of choosing 3 ball will be 120. When we simplify, it's going to be by 4 1, by 4 30, so 1 over 30. This is the probability of selecting all black balls. The second one B, it says at least one ball is white. At least one ball is white means at most even the 3 balls, the 2 balls are white, it's okay. Even at most all the 3 can be white. That means one white means for combination 1, and the other 2 can be red. 2 combination, the red are 2, so 2 combination 2. This is one case, plus again one white and the other 2 can be black. That is for combination 2. Still one white, the other 2 can be one red and one black. That means 2 combination 1 and 4 combination 1. Plus I will continue. This is all for one white. If one of it is white, the other 2 can be red and the other 2 can be black, or the other 2 can be one red and one black, it's okay. But if 2 of them are white, the other can be red to 1. Or if 2 of them are white, then the other one can be black for combination 1. The last possibilities, all the 4 can be white. Divide by, that is 10 combination 3. We did it actually. This one is 120. We got it. This time I would like to repeat some thing here. First of all, what does the question says? At least one white ball. At most, all the 3 can be white. So that if one is white, let me represent it by the white color. This is white, 1 white and 2 red, and this is also white, or 2 black, 2 black, and I mean this one 2 red, because the number of reds are 2. So if I choose one white, the other 2 can be red. One white and the other 2 can be black, or one white and the other 2 can be red and black. 1 it's okay. When you go to the second chance, that means when the white is 2 white and one of it can be red, or 2 white and the other one can be red, or all the 3 can be white. These are the possibilities. Therefore, now let us calculate each of the combination. It is very simple to get the result of the combination this time, because it's combined, most of them are with 1. So for combination 1 it's 4, to combination 2 it's 1, and for combination again 4. Here for combination 2 you can check it, which is 6, and here 4, and 2 1 is 2, and 4 1 is just 4. Again 4 2 6, and 2 1 just 2. 4 2 6, and 4 1 is 4, and for combination 3 also it is 4. When you do it, it's going to be 4 times 1 will be 4, plus 4 times 6 24, plus 16 times 2 will be 32, plus 12, plus 24, plus 4, divided by 120. So when we simplify this, the answer is going to be, when you add the numerator part, it's going to be 100 over 120. Then you can cancel the 0 here, and 10 over 12 remain. Still we can simplify, which is 5 over 6. Next question. 2 students are selected from a class of 28 girls and 22 boys, and one after the other. What is the probability that the second student selected is a boy, given that the first one was a girl? Already one is chosen. So what is the probability the second to be a boy? The number of boys will remain the same, because the first one, consider it is already chosen as a girl. So the number of boys will remain the same. That is 28 chance we have. Out of the sum of the 2 is, it is 50. But one girl is already taken out. So the total number will reduce without replacement. So it will be 49 chance we have. This one is so simple, but the way how to do is this one. Just to repeat, 2 students are selected from a class of 28 girls and 22 boys. Actually this must be 22 boys, one after the other. What is the probability that the second student selected is a boy, given that the first one is a girl? So one girl is already chosen, consider. Now the second, in the case of second choice, what will be the chance to be boy? A boy, the number of boys are remain the same, 22 boys are there, but the number of girls reduce. But the total number, at the beginning it was 50, you can add the total number, it was 50, but in the second choice already the number of students will reduce by 1 girl is already taken, so we have 49. So 22 over 49 will be the answer. Next question. From a pack of 52 playing cards, 3 cards are drawn, one after the other, without replacement. What is the probability that Ace, King and Jack? The probability of Ace, King and Jack. To get Ace, in the first choice, we have 4 chance out of 52 total. In the second choice, to get the K, still we have 4 chance, but out of 51. The total number reduce. In the second choice, getting the J, still it is 4 chance out of 50. The total number of the card is reducing by 1 because it says without replacement. Try to observe the statement here. It says without replacement. The total number is decreasing. So when we calculate this, we can simplify by 4, 1, this by 4, 13. And again here in the last bracket we can simplify by 2, 2, this by 2, 25. Then when we multiply the numerator part, 4 times 2 will be 8, but the denominators 3 numbers will be multiplied, then it's going to be a larger number. That is the probability. Okay, the last question. A box contains 12 bulbs with 3 defective. Total we have 12, and 3 defective means the 9 are non-defective, obvious. If 2 bulbs are drawn at random from the box, what is the probability both bulbs are defective? In case of A, both defective means 3 combination 2. Choosing 2 from the 3, divide by 12 combination 2, which is 3 combination 2 is 3 and 12 combination 2 it is 66. I think we did it in the previous one. 12 combination 2 it is 66, here it is. Therefore let's get back. When you simplify by 3, 1 is by 3, 22. So the chance will be 1 over 22. The B1, both are non-defective. Non-defectives are 9. So from the 9, choosing 2, divide by 12 combination 2. 9 factorial to me, 9 combination 2, let's do it. It is 9 factorial over 9 minus 2 is 7 factorial times 2. And 9 factorial means 9 times 8 times 7 factorial, and this goes. And by 2, 1, this by 2, you know, it's 4, and 4 times 9 will be 36. So that's going to be 36 over, the total is 66. We can simplify by 6 both. This is going to be 6 over 11. So the answer will be 6 over 11. The last one, 1 bulb is defective. 1 bulb is defective means necessarily the other must be non-defective. So we have the chance 3 combination 1 times 9 combination 1, the whole over 12 combination 2. 3 combination 1 is 3, multiply with 9, 9 combination 1 is 9 over 66. We can simplify here by 3, 1, this by 3, 22. We can now simplify further, 9 over 22 will be the answer. So these are some of the questions that I prepared as an exercise on probability. Surely I will get back with another video. Thank you.